early universe and supermassive black holes. It's hard to believe for those who were not there witnessing the launch, but the ground in French Guiana literally shook as the rockets on the launch vehicle ignited. It was the morning of December 25, 2021. The James Webb Space Telescope was just a matter of hours away from its laboratory, space. When it left the Earth, astrophysics was quite different than it is today, and so was our comprehension of the cosmos. Astronomers used to think that, yes, galaxies are where stars are born, and therefore there must be some mechanism, more or less sufficient, helping them to ignite. All the models they had about this mechanism were shown to be flawed because James Webb's observations did not match the predictions. After all, it is the most powerful telescope humanity has ever had. Webb could see what we had never seen, probing the universe where no other telescope had reached before at a distance that amounts to looking back into the past and unveiling the universe as it was just 500 million years after the Big Bang. Webb saw very young galaxies filled with stars. The news? They were all much, much brighter than any astronomer would have guessed. Our telescope hinted that these youngsters may have been more efficient at creating stars than previously thought. Not only that, astronomers found out they had been thinking wrong about black holes all this time. Ever since Einstein's predictions of the existence of such objects, science has managed to make some huge steps regarding black holes. Some scientists even took pictures of them, confirming once and for all that those 100-year-old predictions were in fact correct, and that in other words, black holes are real. Nevertheless, there is still so much we have to learn about these big monsters of the cosmos. For instance, we know some of them devour passing stars in clouds of gas and dust, going from being classified as black holes to what is known as supermassive black holes. A supermassive black hole is just a chubby black hole. How does this relate to Webb, you may ask? Good question. The thing is, our buddy has found a bunch of supermassive black holes lurking in the early universe. This left astronomers speechless, as where the hell did these black holes even find the time to grow this much? And where in the universe did they find such an enormous quantity of food? After all, the quantity of matter in the early universe must have been way less than the one we see all around us today. This is a puzzling problem that today's and tomorrow's scientists are and will try to address. Studies that try to address how these behemoths evolve will only be possible thanks to James Webb. Another frontier has been unlocked. The true Hubble constant's value. Leaving for a moment the early universe behind, allow me to explain how James Webb, who is very good with numbers, could tell us a bit more about how we came to be in the first place and how we, and in fact the whole universe, will end. There is a constant, perhaps one of the most important numbers to describe the universe we live in. It goes by the name of Hubble constant, and it measures the expansion rate of the universe. A positive value of it means the universe is expanding. A negative one, well, is telling us that everything is inevitably getting closer as time passes by. The higher the Hubble constant's absolute value, the faster the expansion, or the contraction. Hubble was the first one to notice that this constant could actually be measured. He did so by observing Cephalid variable stars and Type 1a supernovae, which are very good proxies to constrain the expansion of the universe, as they are very bright objects and can be detected at million light-years of distance. Luckily enough, Sir Hubble found our universe is expanding. This means that the Hubble constant is positive, and we don't have to worry about getting squeezed by other galaxies or swallowed by an approaching black hole. Measurements based on the observation of the cosmic microwave background model combined with the standard model of cosmology yielded a value of 67 kilometers per second per megaparsec for the Hubble constant. When the Hubble telescope, James Webb's predecessor, kicked in, it provided us with a much better estimate of 73 kilometers per second per megaparsec, meaning that the universe was expanding much faster than previously thought. This groundbreaking discovery has been confirmed to a much higher degree of precision by Webb itself. Having confirmed the absolute value of 73, what does this tell us about our model, giving 67 instead? Simple. We're wrong. Perhaps there's still something we're missing in our models, and this is Webb's way to tell us, look, you're wrong. Future studies might delve deeper into this open problem. For now, the only sure thing is we are moving away from all other galaxies, and all galaxies are moving away from us too. This process will likely continue for billions of years, even when James Webb, you, me, and Earth as a whole would have long disappeared. stellar jets in stellar nurseries. Hey, speaking of you and me, imagine if I put myself between you and the TV while you're watching your favorite series. I bet you'd throw something at me. Something very similar happens to astronomers all the time, especially when their favorite series is newly formed stars. Stars form in dense clouds of gas and dust. These block visible light, and a normal telescope is blind to what happens behind the cloud shield. It doesn't really matter how big or powerful your telescope is. It doesn't even matter if you observe from the ground or from space. If the cloud is dense enough, you'll never be able to see the newborn star. James Webb offers a unique way to understand what is going on behind the dust grains. Its infrared vision allows us to see stars' birth in great detail. You see, starlight is actually made of multiple wavelengths. Clouds are only capable of shielding the optical ones, which are rather short if compared to the red part of the spectrum. The redder wavelengths can pierce through the clouds and reach James Webb's mirror. They also reach Hubble's mirror, but Hubble is blind to infrared radiation. Infrared light from objects in the universe also falls and hits our eyes, but we're not built nor meant to observe that regime of the electromagnetic spectrum. What JWST revealed was thousands of new stars buried within the Eagle Nebula and RHO Ophiuchi complexes. Some of these newborn stars have been observed to emit high-speed jets of material, which in turn lights up surrounding clouds of molecular hydrogen. In this image, the RHO Ophiuchi cloud complex is shown. It is the nearest star-forming area to Earth, and it has been captured here in a close-up image by Webb. Despite being a relatively small and tranquil stellar nursery, the chaotic nature of the image reveals jets emanating from young stars, intersecting with interstellar gas and illuminating the red molecular hydrogen shown in red. If you look closely, you might notice that certain stars exhibit the distinct shadow of a circumstellar disk, indicating the potential formation of future planetary systems. Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Exoplanetary Atmospheres. The study of newborn stars is very fascinating, and so little is known about stars' first evolutionary steps. Studying these stars' disks can also help uncover the complex mechanisms of planetary formation. However, these stars will never showcase any formed planet. They're just too young for planets to have formed. If you want to take a look at exoplanets, you might want to point your instruments to stars in more advanced evolutionary phases. Around them, astronomers have found a handful of planets, and who knows, maybe one of them has all the ingredients to host life as we know it. The very flexible James Webb can address the life potential of these mysterious celestial objects. It cannot directly take pictures of them, but it can do much more. How does it do it? Take spectra, for example. Spectroscopy is highly significant in the explorations conducted by JWST. By utilizing this technique, astronomers can determine the distances of galaxies located far away, examine the composition of stars, and analyze the atmospheric composition of exoplanets. The James Webb Telescope is well suited for each of these tasks, but it is the latter that has provided particularly intriguing findings. Notably in the planet K2-18b, which exists within the habitable zone of its star. Methane, carbon dioxide, and dimethyl sulfide have been detected. On Earth, dimethyl sulfide is exclusively generated by phytoplankton, organisms that reside in the ocean. This discovery raises the possibility of an extended water ocean being present on K2-18b. Only time will reveal whether this exoplanet is home to these tiny organisms that, akin to phytoplankton on Earth, are responsible for the spectroscopic line of dimethyl sulfide detected by Webb. The Solar System. James Webb's amazing capabilities are not limited to the deep universe. This marvel of engineering is also well capable of probing the solar system. During its mission, Webb was tasked with observing Saturn, Jupiter, Neptune, and Pluto, together with their moons. The first near-infrared observation of Saturn took place on June 25, 2023. In Webb's picture, Saturn is spotted under a different light. It appears extremely dark because methane gas, present all over the planet in great quantity, absorbs almost all of the sunlight falling on the atmosphere, and the infrared radiation signal is therefore very low. However, the icy rings stay relatively bright, leading to the unusual appearance of Saturn in the image. The image of Saturn illuminated in an unprecedented light captivates all who see it. The presence of moons Dione, Enceladus, and Tethys adds to the enchantment. Only a month prior, Webb's assistance led to the discovery of a remarkable water vapor plume emanating from Enceladus' southern pole. This jet was so forceful that it extended a staggering 20 times larger than the moon itself. The inset, showcasing an image from the Cassini orbiter, starkly contrasts Enceladus' size in the Webb image with the magnitude of the water plume. Prior to the Webb telescope's arrival, scientists were aware that plumes like the one depicted in the image were responsible for supplying water to Saturn and its rings. However, they never had the opportunity to witness this process firsthand. Webb provided the first ever glimpse into this phenomenon, allowing researchers to observe it in action. Through a detailed analysis, it was determined that 30% of the water remains within the rings, while the remaining 70% escapes and provides water to the rest of Saturn's system. Enceladus, an ocean world, holds immense scientific importance and is considered one of the most intriguing targets within our solar system. Did you notice how our eyes are starting to get accustomed to the unique style of pictures delivered by James Webb? James Webb's images are truly one of a kind and easily recognizable. Let's take a look at this particular image. At first glance, it may resemble Saturn with its rings, but it's actually Neptune as observed by Webb. The picture captures Neptune's 7 moons: Galatea, Naiad, Thalassa, Despina, Proteus, Larissa, and Triton. Can you spot Triton? It shines brightly in this Webb portrait, accompanied by the signature diffraction spike seen in many of Webb's images. If you want to know more about Neptune as seen by Webb, we have already made a video for you. Check it out. To really understand how amazing James Webb's pictures are, let's compare them to pictures taken by the Hubble Space Telescope. Look at these images of Uranus, for example. When you put them next to each other, you can see that the James Webb Space Telescope, JWST, is way better at taking pictures in infrared than NASA's Hubble. Back in 1986, Voyager 2, a space probe that's still sending data 45 years after it launched, found 2 new faint rings around Uranus during a flyby. This added to the total number of rings, making it 11. Interestingly, only Voyager 2 and the Keck Observatory on Earth could see these 2 new rings clearly. Hubble, even though it saw 2 other faint outer rings 20 years ago, making the total known rings 13, didn't see the ones Voyager 2 found. The difference is in how they see things. Hubble looks at ultraviolet, visible, and a little bit of infrared light, while JWST looks at the whole infrared spectrum. What makes Webb special is its much bigger mirror, which gives us better, more detailed pictures in infrared compared to Hubble. This really shows in its amazing images, especially when looking at cool things like Uranus. On the right side of Uranus, there's a brightening at the pole facing the Sun, called a polar cap. This cap is unique to Uranus. It shows up when the pole is in direct sunlight in the summer and disappears in the fall. The data from Webb will help scientists figure out how this works. Near the edge of the polar cap, there's a bright cloud and some fainter features just beyond the cap. On the planet's left side, there's another very bright cloud. These clouds are normal for Uranus in infrared, and they're probably connected to storms. Hey, if you're still around, just a quick reminder that we've already delved into most of the content featured in this video in greater detail in our earlier videos on the channel. Choose your favorite James Webb discoveries and explore them in more depth by checking out those videos. The most distant star in the universe. Did you know that according to Einstein's general theory of relativity, bodies with mass can deform the space-time around them? Yes, you heard it right. The greater the mass of the object, the more significant the deformation of space-time. When light passes through these deformed regions of space-time, it gets diverted and bent to varying degrees depending on its relative position to the mass, causing the space-time deformation. Galaxy clusters are among the most massive objects in the universe, and consequently their deformation effect is extremely high. Gravitational lensing gives us the chance to look at some of the furthest objects in the universe. Objects that we would not be able to spot if it weren't for general relativity. In 2022, Hubble discovered Arundel, a star in the Whale constellation. This can be found at the enormous distance of 12.9 billion years from us. This means we are observing it as it was almost 13 billion years ago, which makes it the oldest and most distant star we know of in the entire universe. Arundel was discovered by chance, but astronomers decided to follow it up with Webb. The main reason behind this choice is that Hubble's observations have not been sufficient to give enough information about Earendil's mass, as most of the information on the star is enclosed in its infrared emission, which Hubble is not able to detect. Here's where James Webb kicks in. Using the infrared wavelength-sensitive instrument on board Webb, observations have revealed that Earendil is a blue supergiant star with a mass between 50 and 100 times that of the Sun. It is twice as hot as the Sun and approximately 1 million times more luminous. Due to its mass, Earendil is expected to explode in a supernova within a few million years. Astronomers have also identified hints in the data of a possible companion to Earendil, a cool, redder, and less luminous star, which will require further analysis and observations for confirmation. Webb's Earendil observation has allowed astronomers to open a new window into the properties of the primordial universe. All the physics of the stars known to us is based on the assumption that all stars in the universe have the same properties as those directly observed around us in the Milky Way. Being able to directly see a star so far away allows for an investigation into whether this assumption is correct or not. If not, it could disrupt current knowledge about the universe. Additionally, the observation of Earendil is another step, according to astronomers, towards eventually detecting the so-called Population 3 stars, which are the first stars formed in the universe. These stars are made up only of hydrogen and helium, but have never been observed before. Will James Webb unveil their secrets? NGC 5068. Although the primary focus of the James Webb Telescope is to gather valuable scientific data, there are instances where the visually stunning images it captures are considered valuable scientific discoveries themselves. An excellent example of this is the breathtaking portrait of NGC 5068, a spiral galaxy located approximately 17 million light-years away. This galaxy stands out due to its extraordinary rate of star formation. By utilizing the various instruments on board the telescope, a team of astronomers successfully captured the galaxy's beauty in great detail. These images not only aid in the comprehension of star formation and evolution, including those similar to our own solar system, but they also serve as amazing wallpapers for cell phones. This picture showcases an assembly of countless tiny stars forming a dense, whitish bar, which serves as the galaxy's focal point. Intricately woven clusters of dust, clumps, and filaments gracefully follow the spiral's arm's twists, creating an almost skeletal structure. Hidden within the dust, one can distinguish the presence of large, radiant bubbles of red gas, further enhancing the captivating tapestry of NGC 5068 with an ethereal touch. Jupiter. Let's leave this galaxy behind and come back to the Milky Way. More precisely, let's go at around 8 kiloparsecs from the center of the Milky Way. Here you can find the solar system, and within it, there's Jupiter. A mesmerizing planet, especially if you look at it through Webb's lenses. The telescope took a wide-field view of the enormous gas giant and its faint rings. Yes, if there's one thing you learned today is that, well, basically all planets have rings, not just Saturn. In this pic, the fuzzy spots in the lower background are likely galaxies photobombing this Jovian view. This one image sums up the science of our Jupiter system program, which studies the dynamics and chemistries of Jupiter itself, its rings, and its satellite system. But Webb decided to take yet another picture. This time, it is Jupiter close up. Jupiter is a planet full of intense weather phenomena like storms, winds, auroras, and extreme temperature and pressure conditions. Recently, the James Webb Space Telescope from NASA has captured new images of this fascinating planet. By observing Jupiter through Webb, scientists hope to gain further insight into its inner workings. In one of the images composed of multiple shots taken by Webb, the auroras can be seen stretching high above both the northern and southern poles of Jupiter. These auroras glow in reddish hues due to the use of a specific filter, which also brings out the reflection of light from the lower clouds and upper hazes. Another filter, highlighting yellows and greens, reveals swirling hazes around the poles. Furthermore, a third filter, emphasizing blues, displays light reflected from the planet's deeper main cloud. Interestingly, the Great Red Spot, a well-known storm on Jupiter that is large enough to engulf Earth, appears white in these images, as do other clouds on the planet. This is because they reflect a significant amount of sunlight. Spiral Galaxy's Family Portrait. Webb has recently been occupied with photographing several nearby spiral galaxies, precisely 19 of them. This marks the beginning of a larger ongoing project known as FANGS, which stands for Physical and High Angular Resolution in Nearby Galaxies. The primary objective of this endeavor is to comprehend the interaction between small-scale gas and star formation physics, galactic structure, and the evolution of galaxies. The sheer beauty of these spiral galaxies is absolutely incredible. I mean, look at them. These images are capturing the essence of millions and millions of stars. Some of them are spread throughout the galaxy's spiral arms, but others are clumped together in star clusters. Some stars haven't yet fully formed, and you can find them encased in the gas and dust that feed their growth. Ring Nebula. Just as Webb can observe newly formed stars, it is also able to capture breathtaking images of their demise. Consider the Ring Nebula. It is the outcome of the final stages in the life cycle of a star similar to our Sun. As a star like the Sun depletes its nuclear fuel, it goes through a series of changes. In this particular case, the central star has expelled its outer layer of gas into space, forming a luminous shell of ionized gas. The remaining central star situated at the core of the nebula is a white dwarf, a dense and hot remnant of its former self. This is how Hubble was seeing it. The colors observed in the Ring Nebula result from different gases within the nebula becoming ionized by the intense ultraviolet radiation emitted by the central star. Located roughly 2,000 light-years away from Earth, this celestial object is a favorite target for amateur astronomers due to its unique appearance and notable brightness. The James Webb Space Telescope, however, aids in distinguishing the most intricate details. Furthermore, upon closer inspection, one can notice the presence of stars that extend beyond the obscuring dust. Webb's infrared capabilities make this possible, enabling it to consistently peer further into the depths of space. Jupiter's moons. Last year was amazing, with that historic first look at Jupiter, Uranus, Neptune, and Mars through Webb's incredible lenses. But this year has been more about the steady stream of data and cool new discoveries rather than those jaw-dropping visuals. First up, let's dive into the fascinating moons of Jupiter. This is Ganymede, Jupiter's largest moon and the biggest in our entire solar system. Scientists have long been curious about the possibility of geysers spewing material from Ganymede's interior out into space. To unravel these mysteries, they recently pointed the powerful James Webb Space Telescope at Ganymede, searching for signs of hydrogen peroxide blasting off its surface. This hydrogen peroxide phenomena is triggered by charged particles, some trapped by Jupiter's mighty magnetosphere, others from the Sun's solar wind, slamming into Ganymede's surface. These collisions break apart surface molecules, creating those clouds of hydrogen peroxide we've detected. By mapping the concentrations of this hydrogen peroxide, astronomers have been able to measure the interaction between Ganymede and the various charged particles in its environment. Next, the James Webb Telescope set its sights on Io, the most volcanic moon in the solar system. With its fiery volcanic activity, Io is a true spectacle. Webb measured concentrations of sulfur dioxide erupting from specific volcanoes on Io's surface. When these measurements are paired with images from the Juno spacecraft, scientists gain a comprehensive understanding of Io's dynamic interactions with its surroundings. Then, Webb turned its gaze to Europa, one of the solar system's most intriguing moons. Europa, another large icy moon, harbors a liquid water ocean beneath its frozen shell. A major question for astronomers is how this ocean interacts with the icy crust and how much of this interaction vents into space. Webb's observations revealed concentrations of carbon dioxide in specific regions of Europa. The presence of carbon dioxide on Europa's surface is puzzling, as it should be blown away due to the lack of atmosphere. This implies a replenishing source of carbon dioxide, hinting at potential geysers on Europa. Could it be European space whales exhaling carbon dioxide into space? Probably not, but this discovery adds another layer of intrigue to the potential for geysers on Europa. Although Webb didn't detect any geyser plumes, these findings offer valuable insights and fuel further curiosity about the mysterious moons of Jupiter. The next discovery is truly fascinating. Take a look. Uranus's faintest ring. Let's journey farther out into the solar system to the icy giant Uranus. In the first year, we were treated to an incredible image of Uranus taken by the James Webb Space Telescope, a favorite for many. Now we have an even more spectacular image, likely the best planetary image captured by Webb in its second year of operation. You're seeing Uranus tilted completely on its side, providing a unique view down one of its poles. The planet's rings are visible face-on, but what's truly remarkable about this new image is the visibility of the faint, diffuse Z-ring, which wasn't seen in the earlier image. Capturing images of Uranus is quite challenging due to its rapid rotation, only 17 hours for a full spin. Initially, astronomers were unsure if Webb could handle imaging such fast-moving objects within our solar system. However, these 2 past years have proven Webb's capability, as it successfully captured images of rapidly rotating planets like Mars, Jupiter, Saturn, and of course Uranus. These stunning images highlight Webb's extraordinary achievements in our solar system. Beyond these visual wonders, Webb has made numerous significant scientific discoveries, including observations of Kuiper Belt objects, asteroids, and active asteroids. While many fantastic images were taken this year, we will show you what we consider the very best. Exoplanets. Most exoplanets are detected using indirect methods, such as the transit method or the radical velocity method. But with the James Webb Telescope, we get a more fascinating and nuanced understanding of these exotic planetary systems. By watching as a planet passes in front of its star, Webb can focus on the light coming from the planet's atmosphere, which will tell us what it's made of and if it has weather patterns. One of the most interesting systems we're looking at is the TRAPPIST-1 system, which has 7 planets that are similar in size to Earth. At least 4 of these planets are in the habitable zone, which means they might have liquid water on their surfaces. This raises the possibility of finding atmospheres that could support life. There's a lot of excitement around TRAPPIST-1, and scientists are eager to find out if these planets have atmospheres. But the initial results have been surprising. The first 2 planets, TRAPPIST-1b and TRAPPIST-1c, don't seem to have any atmosphere at all. This is unexpected, as we thought they might be similar to Venus, with thick atmospheres. Instead, they're more like Mercury or the Moon, with no atmospheres to speak of. The intense radiation and solar flares from the star are probably responsible for stripping these planets of their atmospheres. So, we're now focusing on the other planets in the system. Webb has collected data on TRAPPIST-1d and the others, but we haven't heard any announcements about whether they have atmospheres or not. Most scientists think that these planets orbiting small, cool stars like TRAPPIST-1 are likely to have their atmospheres blown away by the intense solar flares. While Webb is a powerful tool, it might not be able to detect the presence of atmospheres on these planets. We'll have to wait and see, and possibly rely on future telescopes like the Habitable Worlds Observatory to image Earth-like planets orbiting Sun-like stars and measure their atmospheres. An exomoon around a brown dwarf. Let's take a journey a bit further into the cosmos to explore the fascinating world of brown dwarfs. These mysterious objects are often described as failed stars because they lack the mass required to sustain hydrogen fusion in their cores. These celestial objects exist between the boundary of planets and stars. One of the most intriguing questions astronomers are currently grappling with is whether there are moons orbiting around exoplanets. Here in our solar system, moons are abundant, but we have yet to discover an exomoon, a moon orbiting an exoplanet. However, this year David Kipping and his team are on the hunt for these elusive exomoons. We might have to wait for a future update on their findings, so stay tuned for that. Recently, we received a tantalizing hint of an exomoon orbiting a brown dwarf thanks to the James Webb Space Telescope. While observing a brown dwarf, James Webb made the surprising discovery of methane in its atmosphere. This was unexpected because methane typically shouldn't be present in the atmosphere of a brown dwarf. This discovery suggests some kind of temperature inversion where something is heating the exterior of the brown dwarf, allowing methane to appear in the upper atmosphere. But that's not all. The brown dwarf also exhibits auroras, much like the northern and southern lights we see on Earth. On Earth, auroras occur when charged particles from the solar wind interact with our planet's magnetosphere, creating beautiful displays of light. However, the brown dwarf doesn't have a partner star to supply such solar wind. This implies that the brown dwarf must be generating these auroras internally. Here's where it gets even more intriguing. There's a theory that if a moon were orbiting a brown dwarf, it could pass through the brown dwarf's magnetosphere and generate auroras. This could potentially be the first indirect evidence of a moon orbiting a brown dwarf. So, thanks to the James Webb Space Telescope, we might be on the verge of discovering something incredible: the first exomoon orbiting a brown dwarf. It's a discovery that could change our understanding of these cosmic bodies and the moons that may orbit them. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. The first Hycean world. When we think about planets, we often focus on the habitable zone, the region around a star where liquid water can exist on an exoplanet's surface. However, in recent years, a new type of planet has been proposed: Hycean worlds. These planets have a thick hydrogen atmosphere surrounding a liquid water surface, combining hydrogen and ocean, hence the name Hycean. A thick hydrogen atmosphere acts as an insulator, allowing liquid water to exist on the planet's surface. This means that the traditional concept of the habitable zone is no longer applicable. Hycean worlds can have liquid water on their surfaces, even if they are much closer or farther from their star than traditional habitable zone planets. One of the most promising candidates for a Hycean world is K2-18b, located about 120 light-years from Earth. This massive planet is roughly 3 times the size of Earth. Thanks to the James Webb Space Telescope, astronomers have detected the presence of both methane and carbon dioxide in K2-18b's atmosphere. These findings suggest that K2-18b might be one of these Hycean worlds. Additionally, astronomers have detected a faint signal of dimethyl sulfide (DMS) in the atmosphere. On Earth, DMS is almost exclusively produced by life, particularly by phytoplankton. This raises the intriguing possibility that K2-18b could be a water world with giant blooms of phytoplankton producing DMS. However, confirming the presence of life is not straightforward. To detect such a clear signal of DMS in K2-18b's atmosphere, the concentration would need to be about 20 times higher than what we see on Earth. The problem is that the signals for methane and DMS overlap. This means that the detected DMS signal could be an error caused by the stronger methane signal. Moreover, there are other possible explanations for K2-18b's atmospheric composition that have nothing to do with water or life. Another team of astronomers analyzed the data and proposed that K2-18b might be a world covered in lava. They based this hypothesis on the absence of ammonia in the planet's atmosphere. If K2-18b were a water world, they would expect to see ammonia alongside methane and DMS. The lack of ammonia suggests that K2-18b might instead be a rocky world covered by lava. Earlier this year, there was a flurry of excitement with several channels claiming that life had been found on K2-18b. However, these claims are premature. While the detection of DMS is intriguing, it is not definitive proof of life. The possibility remains that the signal could be a false positive, or that other non-biological processes could produce the observed atmospheric chemicals. As research continues, astronomers are working to refine their observations and analyses to determine the true nature of K2-18b. Whether it is a Hycean world with potential signs of life or a rocky lava planet, it remains a fascinating subject of study. Future observations and missions will provide more data to help unravel the mysteries of this distant world. So, keep your fingers crossed and stay tuned as we will explore new updates in future videos. Methane in an exoplanet atmosphere. Let's explore a Jupiter-like planet called WASP-80b, which is located in a distant part of the galaxy. Unlike hot Jupiters that orbit very close to their star, WASP-80b is more like a warm Jupiter with a surface temperature of around 550 degrees Celsius. The James Webb Space Telescope was able to observe the planet passing in front of its star, measuring the atmospheric chemicals of this distant world. One exciting discovery was the detection of methane, which was also found in the earlier mentioned brown dwarf. Methane is particularly intriguing because it is a short-lived chemical. On Earth, most atmospheric methane is produced by life, including rotting vegetation and various bacteria. However, there are also inorganic ways to generate methane, such as volcanic activity. Take, for instance, Titan, a moon of Saturn, which has lakes of liquid methane, with methane rain. Despite this, the methane on Titan was likely created through some kind of inorganic process. What will be more interesting is to study how the presence of methane interacts with other chemicals in the atmosphere, such as carbon dioxide, carbon monoxide, and water vapor. By observing the interplay of these chemicals in the atmosphere, it may be possible in the future to determine whether there is life on a distant exoplanet. Weather patterns on an exoplanet. We cannot yet directly observe the weather on exoplanets, but for some nearby worlds, the James Webb Space Telescope can analyze the atmosphere to determine its composition and what the weather and climate are like. An international team of researchers did just that for the exoplanet WASP-43b. WASP-43b is a tidally locked exoplanet that orbits its star at an incredibly close distance of about 1/25th the distance from Mercury to the Sun. Astronomers have been studying this planet using the James Webb Telescope, which has allowed them to map the concentration of chemicals in its atmosphere and even measure its weather patterns. When WASP-43b transits in front of its star, it creates 3 distinct transits, allowing scientists to observe the planet's atmosphere as it passes in front of, behind, and reemerges on the other side of the star. By analyzing these transits, researchers have discovered that the planet's atmosphere has a striking difference between its day and night sides. The night side, which faces away from the star, is covered in clouds, while the day side, which faces the star, has clear skies. Furthermore, the planet's atmosphere is characterized by enormous equatorial winds that blow at an astonishing 8,000 kilometers per hour, distributing material from the day side to the night side. This unique weather pattern has significant implications for our understanding of tidally locked planets, including those that orbit red dwarf stars, which are similar to the TRAPPIST-1 planets. Although we don't yet know if the TRAPPIST-1 planets have atmospheres, studying the weather patterns of WASP-43b provides valuable insights into how they might behave. As the James Webb Telescope continues to explore the atmospheres of exoplanets, we may uncover more secrets about the weather patterns of these distant worlds and their potential for supporting life. But now, get ready for one of the most remarkable discoveries so far: water delivery to new planets. One of the oldest mysteries in planetary science is the origin of Earth's water. Given its proximity to the Sun, it's unlikely that water could have survived on the planet's surface without the protective shield of the atmosphere and magnetosphere, which defend against solar wind and radiation. In the early days of Earth, when these defenses were absent, any surface water would have evaporated and escaped into space. Therefore, scientists have long believed that water must have been delivered to our planet at a later stage. But where did this water come from? One compelling theory is that comets from the outer solar system, possibly originating from Kuiper Belt objects or icy particles closer to the inner solar system, gradually accumulated on Earth. Recently, the James Webb Space Telescope has provided groundbreaking evidence to support this theory. Observing a distant star system, the telescope detected water particles drifting from a distance comparable to Neptune's orbit towards the inner part of the system. This phenomenon mirrors the icy pebble drift theory, a leading explanation for how planetary systems obtain their water. The James Webb Space Telescope's observations offer a glimpse into the exoplanetary system, where water is being delivered to its inner regions, providing crucial evidence for this theory. A planet with clouds made of sand. You're probably familiar with violent sandstorms, but can you believe that somewhere in the depths of the universe is a planet with clouds made of sand? This incredibly fascinating world is WASP-17b. The distant exoplanet is known as a puffy Jupiter due to its large outer atmosphere, which is heated up to a scorching 1500 degrees Celsius. Despite being almost double the size of Jupiter, it has only about 78% of its mass, resulting in a very low density that makes it seem puffed out. Astronomers were intrigued by this unusual world and wanted to investigate what kinds of chemical processes could occur in its atmosphere that might be different from those seen in our own solar system's gas giants like Jupiter and Saturn. During the research, they made a surprising discovery: aerosols in the atmosphere of WASP 17b, similar to those found on Earth, but with a twist. These aerosols are composed of quartz or sand. The presence of sand clouds on WASP 17b is puzzling, as it requires the crystallization of silicon oxide, which typically occurs when molten liquid silicon oxide cools down. However, the temperatures on this exoplanet are so hot that it's difficult to understand how quartz could form. Instead, it appears that a WASP 17b has found a way to force silicon oxide into crystals under high pressure and high temperature, creating the sand that makes up its clouds. Rogue planets in the Orion Nebula. These could probably be some of the most fascinating discoveries made by the James Webb Space Telescope in its second year. This $10 billion telescope has spotted hundreds of rogue planets in the Orion Nebula, also known as free-floating planets. Although the Hubble Space Telescope identified a few of these several decades ago, Webb's advanced infrared capabilities have revealed many more of these cooler objects, which emit infrared radiation. Webb has identified 540 such free-floating planets in the Orion Nebula, some even smaller than Saturn. Remarkably, 42 of these objects are in orbit around each other, now termed Jupiter mass binary objects or jumbos. This discovery raises many questions about their formation. Imagine a rogue planet like Jupiter floating through space. Did it form in an existing planetary system and get ejected, or did it form independently from a small amount of gas and dust? If it's the former, how do we explain 42 of them forming binary pairs? Were they ejected together, or did two individual rogue planets somehow find each other and begin orbiting? These discoveries leave us with more questions than answers, but indicate that rogue planets are very common. This profound finding reshapes our understanding of the Milky Way, suggesting that, in addition to stars and their binary systems, billions of free-floating planets drift through our galaxy. A key molecule for life. Have you ever wondered where Earth's organic molecules came from? The ones that are made up of various carbon, nitrogen, and oxygen atoms and are essential for life? One possibility is that these chemicals were delivered to Earth and then formed larger compounds here. However, astronomers are discovering more and more examples of these complex molecules existing in space. In fact, all of the amino acids that life uses have been found just floating around in space. And thanks to the James Webb Telescope, astronomers have now discovered an even more basic building block of life. This molecule, called methylcation CH3+, was found in the Orion Nebula, the same place where many free-floating exoplanets have been discovered. It's been theorized for a long time that this molecule exists in space, but it had never been observed before. It's been tricky to find because it chemically wants to bind with other atoms like carbon. Interestingly, this molecule was found in a region that has a tremendous amount of ultraviolet radiation, which was thought to break these molecules apart. However, it seems that this radiation is actually replenishing the reserves of CH3+, which can then form into more complex organic molecule compounds. So, it's possible that we found the source of the organic molecules that were delivered to Earth. In fact, it's starting to seem like the molecules for life formed long before our planet itself formed. Protoplanetary disks in the Lobster Nebula. Now, we are traveling to the Lobster Nebula, also known as NGC 6537, a dense region of space where stars are actively forming. With hundreds of thousands of new stars in the making, there is an abundance of mass and material. As a result, astronomers have observed a greater number of larger stars, classified as OB stars. One question astronomers have is whether these massive hot stars can have protoplanetary disks and potentially form planets. Thanks to the James Webb Telescope, we now have the answer. By analyzing the regions around these big hot stars, The telescope was able to detect the signal of planetary disks, even in such young stars. In fact, the presence of water and habitable zones was confirmed, indicating that planets could indeed exist in these regions. These findings suggest that even the largest and hottest stars are likely to have planets and potentially even habitable zones. This discovery has significant implications for our understanding of the universe and the possibility of life beyond Earth. Herbig Haro 4647. Now let's turn our attention to a pair of newly forming stars, Herbig Haro 46 and 47. These two young stars orbit each other and will eventually become a binary pair. They're embedded in a shared cloud of gas and dust, drawing in material as they interact with each other and the larger gas cloud. This interaction results in unusual outflows emanating from the two stars. When you look at an image of this region, you're observing what's called a Bok globule. In visible light, this would appear as a black cloud, as the dust blocks the starlight. However, with the James Webb Space Telescope's infrared capabilities, we can see through the obscuring gas and dust to observe the area where the stars are gathering material. Over time, these stars will continue to accumulate additional material. Eventually, their powerful stellar winds will blow away the remaining gas and dust, leaving two stars orbiting each other. However, this process will take millions of years to complete. The most distant active supermassive black hole. There's a fascinating phenomenon at the heart of most galaxies. Astronomers believe there's a supermassive black hole in the center. These black holes are usually dormant, but when they're fed material, they spring to life. They build up enormous accretion disks, and their magnetic fields create jets of material that blast out of the galaxy's core. When these jets are directed towards us, we call the phenomena a quasar. However, there's a whole family of active galaxies, including Seyfert galaxies, blazars, and quasars, all showcasing these quasar jets at different angles. Quasars are exceptionally bright, outshining the rest of their host galaxies. As a result, at vast cosmic distances, we often only see the quasar and not the galaxy itself. Astronomers have now found what they believe is the most distant quasar yet, which emits light from when the universe was only 570 million years old. This quasar is an incredible 9 million times more massive than the Sun, double the mass of the black hole at the center of our own Milky Way. But what's even more intriguing is that this quasar, discovered using James Webb's observations, is just one of many. By studying these ancient quasars, astronomers realized that supermassive black holes in the early universe accounted for around 10% of their galaxy's mass. In contrast, in modern galaxies, they only make up about 1%. The question then arises, what has changed over cosmic time? Why do black holes seem to have shrunk relative to their host galaxies? This is a mystery that the incredible eye of James Webb hopes to solve as it continues to peer into the cosmos, shedding light on the universe's earliest days.